All right, we're going to be looking at rational functions in this unit. And what a rational function means is that we've got, we have a fraction. Rational numbers are fractions. Rational functions are fractions. So let's remember some stuff about fractions. We're going to start off with basic ones. Of course, we know what 12 divided by 4 is. That's just 3. But what if we have 0 divided by 4? Well, that's just still 0. What is 4 divided by 0? What happens when you actually divide by 0? Well, we consider that undefined. So these are some important facts that we'll be going back to throughout the unit. Now, I put at the top hyperbolas. Hyperbolas are this shape that is created when you divide one line by another. So let's look at some stuff. Let's remember, what if I had 2 lines that were multiplied? So we're talking about multiplication. We're talking about things like x minus 1 times x plus 2. What kind of graph do we get there? Well, we should know that that's going to give us a parabola. Oops. Let's put that back to standard so we can see it better. That gives us a parabola. Well, when we divide, we get something totally different. So if I actually change that to division instead of multiplication, we're going to get a shape that is called a hyperbola. Now, if you'll notice, there are 2 parts to this hyperbola. We've got one going up and one going this way. Now, if I look at that graph carefully, and I'm just going to kind of jot it down here, it is split. We've got one part going this way, and we've got one part going this way. And there is a spot where they're splitting at. And if I look very closely, it looks like it's at -2. I could almost draw an imaginary line straight down, separating the 2 pieces of the graph. That imaginary line would be the line x equals -2. Now, why is it doing something really crazy here? Well, let's look back at the function for a second. This function is the function x minus 1 divided by x plus 2. What happens as we put in x equals -2? That would give me 0 in the denominator. Well, my goodness, I can't put 0 in the denominator because I'd get undefined. Let's look what's happening to the numbers as we approach -2, and you even see that we get an error there. You can see that the farther we go out this way, the numbers all stay pretty close together. But when I get closer and closer to -2, the numbers start to get bigger faster, and then they jump up. Well, that's because when you divide by a smaller and smaller and smaller number, the fraction as a whole gets bigger and bigger and bigger. So we can talk about the behavior of this graph as it approaches -2. as x approaches negative 2 from the left side, this means from the left, we notice that our function goes up. So if we're coming from the left side, our function goes up. So our graph goes to positive infinity. As we approach negative 2 from the right side, so this means from the right, so looking in the other direction, as we approach negative 2 from the right, we jump down. So f of x goes down to negative infinity. This is called the behavior at the vertical asymptote. This imaginary line I drew in has a special name. Vertical asymptote. A vertical asymptote has several special qualities. Well, for one thing, it makes the graph split, and it goes in separate directions. The next thing is, the reason it's occurring, it occurs because the denominator is 0 at that value. We represent it by this vertical line, and the function never actually touches it. It is never touched. Now let's look at a few of these and see if we can figure out what would be the vertical asymptote. If it occurs when the denominator is 0, that's really all we have to look at. Now there's something else that I want to mention here before we go on. We can also find our x-intercepts very easily. X-intercepts occur when y is 0, right? When y is 0. Now let's think back. We're dealing with fractions. So when is the only time a fraction equals 0? That only happens when the numerator equals 0. So let's look at a few examples here. What if I had f of x equals x minus 7 over x plus 6? My x-intercepts occur when the numerator is 0. So I look at the numerator. What value would make the numerator equal 0? So for the x-intercepts, I'm going to look at what makes x minus 7 equal 0, and that's 7. Now x-intercepts are a point, and I want to make sure we know that, so that's going to be 7, 0. Our vertical asymptote occurs when the denominator is 0, because that's dividing by 0, and that's a no-no. That's x plus 6 equals 0. And we get the equation x equals negative 6. Our vertical asymptote is always going to be an equation. Our x-intercept is always going to be a point. Let's look at another one. What if we have 2x plus 1 over x squared minus 9? Now, one thing I'll note here is I see that x squared minus 9 and I think, I know that. That's difference of two squares. I'm going to factor it. I get x plus 3 and x minus 3. That means this one's going to have two occurrences where the denominator would be 0. That means I'm going to have two vertical asymptotes. I know that sounds crazy, but it's perfectly fine. My x-intercept occurs when the numerator is 0. So I'm going to look at what happens when makes 2x plus 1 equals 0. That's 2x equals negative 1. X equals negative 1/2. So I have the point negative 1/2, 0. Vertical asymptote occurs when the denominator is 0. Well, actually, there's 2 times that that happens when x is 3 and when x is negative 3. So for this one, we have two occurrences there. Let's look at a little bit harder one. Ooh, can't tell anything right off the bat, but I do know that I can factor. The numerator would be x plus 4 and x plus 2. X times x gives me x squared. 2x plus 4x gives me 6x, and 4 times 2 gives me 8. The denominator, x times x, to get multiply to be negative 15 and add to be negative 2, it's going to be a negative 5 and a plus 3. So this one is going to have two x-intercepts. And I hope we're getting to the point where we don't have to actually work it out to solve, to figure out what would make each of these parentheses 0. I know this one would need to be negative 4, and this one would have to be negative 2. My vertical asymptotes, I look at the denominator. What would make each of those parentheses 0? So I've got x equals 5 and x equals negative 3. Now, if I wanted to double check this in my calculator, just a note on how you'd enter that. Just like I entered the example earlier, I put it in parentheses. I would do the same thing here. I'm going to go to my original and put it in parentheses. X squared plus 6x plus 8 divided by x squared minus 2x minus 15. So when we made our little chart here, we said that there was going to be two x-intercepts and two vertical asymptotes. So let's see what happens. I see my two vertical asymptotes, and it looks like I cross the x-axis here and here. Now it does get a little crazy there, but that's okay.